Hey guys, welcome to Unit 8 Lesson 2. Our topic today is Applications with Implicit Differentiation. So I want you to pause the video and try the warm-up. Be careful while you're doing that warm-up. The warm-up gives us a curve and it's asking us to find the derivative with respect to y. So that's what it is different. We have been doing derivatives with respect to x, but this is the first question where we are trying to do the derivative or find the derivative with respect to y. So what do? We're going to apply the power rule. We're going to just apply the same rules that we've known so far. So it's going to be 2y plus, actually it'll be minus because cosine is negative sign. So sine xy, and now I'm going to apply the product rule inside, which would be derivative of x is just 1, and then I'm going to do the chain rule, so it'll be dx over dy y plus the derivative of, now y is just 1 minus 4 times derivative of x with respect to y, dx over dy. And a derivative of a constant is always 0. So this is what I got for my first step. I'm going to distribute this over. So once I distribute the sine xy, I get this. And after that, I'm solving for dx over dy. So I want to put these together and I want to move over this term and this term. So if I factor out dx over dy, I'm left with negative y sine xy minus 4. And I'm going to move that over. So it'll be x sine xy minus 2y. Right? So now my final step is to divide by this whole thing. So it's going to be dx over dy is equal to x sine xy minus 2y over negative y sine xy. You can choose to put the xy in parentheses or just leave it like that. It's nothing, it's not wrong. And that's basically it. So this is the derivative with respect to y. So applications using implicit differentiation. Now that we have learned how to differentiate implicitly, we can use this technique in applications that we are already familiar with, such as finding the slope of a tangent line, finding the equation of a tangent normal line, etc. So the same thing. So I want to go over these notes, pause the video, copy them, and then I'll explain it over. So dy over dx is the slope of the tangent line that we know. The derivative, the first derivative is the slope of a tangent line. I mean, if it's a normal line, it's a negative reciprocal. The original equation gives you the points and the derivatives gives you the slope. The first derivative gives you the slope, right? To get dy over dx at a point, we need to plug in x and y, right? Whenever we want to find the derivative, we want to do for a certain point, all we do is plug in that point into the equation and we get our slope for that point. And this I think we've done all this. We've talked about it all. So just reviewing again, horizontal tangents. Anytime you have a horizontal tangent to the curve, the slope is 0. Means what? Your numerator is equal to 0, not your denominator. So be very careful, right? So it means your numerator is 0. Vertical tangents, slope is undefined, means your numerator is not 0, your denominator is equal to 0. And no tangent exists if for dy over dx equals 0 over 0. So that's basically it. I hope you copied those notes, and let's get started with example 1. It says the points P and Q on the graph of y squared minus xy plus 8 is equal to 0 have the same x-coordinate, x equals to 6. What is the point of intersection of the tangent lines of the graph at P and Q? So it's talking about the x-coordinate. I know the x-coordinate. So what do I need? Can I find my y-coordinate? Let's find our y-coordinate so at least we have the point. So what do? all we're going to do is take my x equals 6 and substitute into the equation. So I'm going to substitute that here. So let's do this. So it's going to be y squared minus 6y plus 8 equals 0. Solve for y. This is a quadratic, so I'm going to factor it. It's y minus 2, y minus 4 equals 0, and make a t-chart, so I get y equals 2 and y equals 4. So these are my y coordinates. So basically when x is 2, so my 2 points are what? 6 comma 2 and 6 comma 4, right? I want to find the points of intersection of these lines. First, I need to know the equation of these lines. So how do I find the equation? I already have the point. I need the slope. So what am I going to do? I'm going to find my derivative, and I'm going to do implicit differentiation, and where I do use the chain rule, right? So this would be what? 2y. I'm going to use a different color actually. Yellow. So it'll be 2y dy over dx minus, I'm going to put this in parentheses because I'm going to use the product rule here. So this was going to be 1 times y plus, it's going to be x times the derivative of y is just 1, and then I'm just kind of doing the chain rule dy over dx, and a derivative of constant is 0, oops, and it's equal to 0, right? So now if I distribute the negative, I get 2y dy over dx minus y minus x dy over dx equals 0. I'm going to put my dx dy terms together, dy over dx terms together. I'm going to factor that out because I want to find the slope, right? And the slope is what? Dy over dx. So dy over dx, it's 2y minus x, and I'm going to move this, add the y to both sides, so it's equal to y. So I get what? My derivative is y over 2y minus x. So that's just the definition of the derivative, or the formula of the derivative. I want to find it at the 2 points. So what are my 2 points? My first point is 6 comma 2, I think. Yep, 6 comma 2. So dy over dx, and I'm going to do of 6 comma 2. This is how you write it. So I'm going to substitute. This is my x, this is my y. I'm going to substitute in here. So what do I get? 2 over 2 times 2 is 4 minus 6, which is what? Negative 1, right? So I got the slope of this point. So I'm going to write the equation also. So it's going to be y minus 2 equals negative 1 x plus 6. So that's my first equation, right? So similarly, I'm going to find the slope for my second point, which is 6 comma 4. So dy over dx of 6 comma 4. Substitute your 6 and 4 in there. So it'll be 4 over 2 times 4 is 8 minus 6, which is 2. So 4 over 2 is 2. So the second equation is going to be y minus 4 equals 2 times x plus 6. Oh, it's x minus 6. My bad. It is minus 6. And it's going to be minus 6 here too. Minus 6. Right? So these are my 2 equations. But wait a minute, I'm not done. I just got the equations, 2 equations. It's asking me the point of intersection of the tangent lines. So these are my 2 tangent lines. Tangent line 1, tangent line 2. We're doing exactly the same thing that we've been doing in the past, but now there's a lot more to it. It's asking us for the points of intersection. So what are the points of intersection of any 2 lines or any 2 curves or anything where they meet, right? So can I set these 2 equations equal to each other and solve? So that would give me my points of intersection. So I'm going to solve the first one for y. If I solve the first one for y, I'm just going to solve it here. I'm going to zoom in and I'll solve it here. This would be y equals, if I distribute it, I get negative x minus plus 8 because it's negative 1. So if I solve this, I get this equation. And for the other one, I will get y equals 2x minus 8, right? So these are my two equations. I want to find the point of intersection of these two equations. So what do? I set them equal to each other or substitute. You could have done that. So, I think setting them equal to each other would be, so point of intersection. Negative x plus 8 is equal to 2x minus 8. Solve for x. I get 3x is equal to 16. X is equal to 16 over 3. So that's my first point. Now I'm going to take that 16 over 3, substitute into either one of the equation, either this one or this one, and get my y coordinate. So if the first one is a lot easier. So negative 16 over 3 plus 8 is what? 8 over 3. So my points of intersection are, so y is equal to 8 over 3. So my points of intersection are 16 over 3, comma, 8 over 3. So that is my final answer. A lot going on with this question, but it is like just do one thing at a time and know what you have to do. Okay? And if you're confused, please let me know. But it's pretty straightforward from what we're doing, just falling back upon what we've done in the past. I want to do one more example with you guys. It says, what are the x values of the points on the graph of this curve? A curve is given. Again, you can try to solve it for y, but when you cannot solve it for y, if you are running into errors or it's very complicated to solve, then you know you will be doing implicit differentiation. So that is kind of a big hint for you. Where the curve has a vertical tangent. Okay, so remember that. What did we talk about? A vertical tangent means the slope is what? Undefined. M is undefined. And what else do we know? That a denominator is equal to 0. Not a numerator. Denominator is equal to 0. So these are two things we can conclude from a vertical tangent line. So what is it asking? It's asking me for the x values. I only need the x values. I don't need my y values. Of the points on the graph where the curve has a vertical tangent. So I know my slope. I know my curve. I need to find the point. So how do I find the point? So I'm going to find the derivative. I'm differentiating with respect to x. So it's going to be 2x minus, and then again I'm going to use the product rule. Here it is going to be y plus x dy over dx plus 2y dy over dx equals 0 because constant is 0. So now let's distribute and solve for dx. That's what you're doing, right? So it's going to be 2x minus y minus x dy over dx plus 2y dy over dx equal to 0. So now I'm going to factor out my dy over dx, and I'm going to move these two onto the other side. So I'm doing two things in the same step, dy over dx, and I'm left with 2y minus x equals y minus 2x, right? So now what do I get? Dy over dx equals, I'm just going to change the color. I get dy over dx is equal to y minus 2x over 2y minus x. So that is my derivative. So now what do I know? I know my slope is the vertical tangent, and what do I know about it? That the denominator, since the vertical tangent, the denominator is equal to 0. So you're going to take the denominator and set it equal to 0 and solve for y. I get y equals x over 2. So once I got y equals x over 2, or I can say x equals 2y, can I not literally, I want the point or I want the x value. Can I not put that into the equation? I really need to find the x value. So I'm going to just put this into my original equation and find my x values. So I'm going to do it here on the side. So wherever I see y, I'm going to type in x over 2. So it's x squared plus, minus x times x over 2 plus x over 2 squared equals 9. So this is going to be x squared minus x squared over 2 plus x squared over 4. And if you simplify this, I'm going to multiply the whole thing by 4, right? So that gets, or you can just add fractions, whatever you feel. And what do I get? I get 4x squared minus 2x squared plus x squared equals 36. Oh. And then add these up. I get 3x squared equals 36. X squared is equal to 12. So x is equal to plus and minus 2 rad 3. So that is my answer. So that's what it asked me. It said, what are the x values? So the x values are, you can find y also by substituting in y if it asked you for the points, but it's not asking you for the point, it just asked for the x value, right? So I don't want you to finish the entire lesson. I want you to go to problem set number 1. So you are going to be doing, we're going to split this lesson into 2 days. Day 1, problem set number 1, 2, and 3. So this is what you're going to be doing for homework. So good luck, guys. If you have any questions, email me, reach out to me.